The key insight of Infinity-RoPE is that instead of relying on absolute positional embeddings, which quickly become meaningless outside the training horizon, we can use relative positional embeddings anchored to a moving local reference frame. Think of it like navigating using landmarks instead of GPS coordinates that become inaccurate over long distances. By focusing on the relationships between adjacent frames, the model can reason about temporal structure indefinitely, even when generating far beyond its original training data. Block relativistic RoPE is the core innovation for handling infinite video. Traditional RoPE, rotary positional encoding, encodes the absolute position of each token, in this case, video frame. Instead, block relativistic RoPE calculates the positional encoding relative to the most recent block of frames. This block acts as a moving local reference. For each frame, its positional encoding is computed relative to the start of the current block. This allows the model to maintain a consistent understanding of local temporal relationships, even as the video extends far beyond the original training duration. Another issue with autoregressive models is limited prompt responsiveness during long generation. The key value, KV, cache stores information from all previously generated frames, influencing subsequent frames. If we want to change the action or style mid-generation, the old KV cache acts as a strong prior, hindering responsiveness. KV flush addresses this by periodically discarding all but the two most recent latent frames from the KV cache. This forces the model to rely primarily on the current prompt and recent history, allowing for immediate action control and cinematic transitions. Finally, RoPE introduces controlled discontinuities in the temporal positional encoding to facilitate scene transitions. By abruptly shifting the temporal RoPE coordinates, we can create the effect of a cut between scenes. Instead of gradually morphing between scenes, the model perceives a sudden jump in time, allowing for more distinct and intentional transitions, mimicking cinematic editing techniques. The magnitude of the coordinate shift controls the abruptness of the transition. The authors demonstrate that Infinity-RoPE significantly improves the quality and controllability of long-horizon video generation. By incorporating block relativistic RoPE, KV flush, and RoPE, a model trained on short 5-second clips can generate compelling, infinitely long videos with cinematic transitions and fine-grained action control. Quantitative evaluations on VBench show state-of-the-art performance in long video subject consistency, background consistency, motion smoothness, and dynamic degree. This opens up exciting possibilities for creating truly dynamic and interactive video experiences, pushing the boundaries of AI video generation.